Baker fam, it's your science teacher, Miss Swinson. I'm here to tell you about this week's work. Today's work is all about seasons. And what a great day for it to be about seasons. Like, let's be real here. It is hot here. I don't know about where you are, but at my house, it was 84 degrees literally yesterday. That's hot. You can't tell? I got a little bit of red. Yeah, I got a little sunburned. But that's okay. We are here together and we're going to talk about seasons and why the Earth's rotation and tilt is the reason why seasons occur. All right, we got a lot of competing light in this room, and hopefully I can get this experiment so where you can see why seasons happen and how seasons happen according to an investigation that we would have done in the classroom, but because we do not have a classroom, thank you coronavirus, my golf ball on a skewer represents the Earth. And the reason why I do that is because there's a lot of different phenomena happening all in the same time, right? So one of the phenomena that we can observe is the rotation of the Earth, right? So the Earth is constantly rotating. Around and around we go. How fast do we go, you say? What you can do is you can actually measure the circumference of the Earth, then divide that by the amount of hours are in a day, right? Because we want miles per hour, or we want kilometers per hour. So kilometers are miles that it turns. And that'll give you the answer to how fast the Earth turns. I would like you to pause this video if you can. Pause it and do that math now. Figure that out now. The Earth turns at roughly 1,000 kilometers or 1,000 miles per hour, roughly 460 meters per second. That's a lot, if you ask me. That's like super fast. That's faster than anything we know on Earth. We're constantly rotating. If I put a dot up here in the middle and down at the bottom, what do you think is going to happen to the amount of daylight that that area gets if the Earth is constantly turning? Let me put a marker here. We have 3 dots. Top, middle, bottom. So, most of you guys know that the temperature of the areas in the middle of the planet are a little hotter, right? That's where a lot of our deserts happen. California is closer to the equator. The center of the Earth is considered the equator, right? So it's spinning, 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 right? So if you continue to spin it like this, so spin, 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 you can actually measure how much time it takes for one, if I put a drill on this, that would be even better, but it would ruin the audio. So if I continue to spin it, you can see that there are a few dots. There's a dot that gets way more sun than the other, right? And one dot that gets a lot less than the other. That isn't very good, right? So, Miss Swinson, why isn't the top of the planet super toasty then? Why is there ice up there too? Well, let me tell you, ice up there, right? So spinning, spinning, spinning. Not only are we rotating in space, but we're also rotating around the sun. The dot that was in the dark now suddenly has a lot of light, has almost the same amount of light as the other one, right? We call this an equinox. The equinox is when all sections of the Earth, right, and that's because of the tilt, all sections of the Earth are equally heated, right? So equally heated. See, you can do the time. Almost all of them right there. See, that's where the shade becomes light, right? And we know that light heats things, right? Last week's experiment. And so we move along and darkness is also the same. So the same amount of night and the same amount of day. And so as it's traveling, it comes back over here. And let's move my light just a little further. It comes back over here. And if you notice, now which part of the earth is getting the less light? Yeah, that's right. The other side. So rolling around here. And it takes 365.25 days for the earth to travel all the way around this sun, all the while rotating, right? So you have parts that are being heated, parts that are being cooled by the absence of heat, right? The absence of this, this energy. So this side's being cooled and this side is being heated, or coolness is, or heat on this side is being released back out that way. And it happens every year, all year long, every day, every second, rotating around and around and around and around and around and around. So using my fake earth and my dots, you realize that around the equator, so this line right here, all the way around, is called the equator. The earth is tilted at 23.5 degrees, right? And because of the tilt of the earth, we have seasons. Because otherwise, if it was straight up and down, the poles would not get alternating temperatures, right? So as it's moving around that sun, this side would always get the same amount. This side would always get the same amount, and this side would always get the same amount of temperature, right? The amount of electromagnetic waves coming at them, okay? From the sun, from our sun. Of course, there are other stars in our solar system that are giving us heat, but that is so minimal that we only see a tiny speck of light during the night, right? And we can't see it during the day because the sun's lights are like shining so far at us. It is literally interfering with every other light. Every other light. You guys can try this at home. You guys can put a planet on there. You can spin it around. You can determine how and when we are in the seasons. So what I'd like you to do this week is I want you to, where are we on Earth? Okay? And name the season. What part of our orbit do you think we are? I want you to draw me a picture of where you think the Earth is compared to the sun right now in a picture. All right, so we have the sun. And there are some secrets that I did not tell you about seasons in this video. You're going to have to figure them out yourself during this week's activity. So we have the sun, and we know that the Earth is somewhere traveling around it like so, right? We know that the Earth's orbit is somewhere around it. Somewhere on that. So what you're going to do is you're going to decide which point of the sections the Earth is. So do you guys think we're right here? Do you think we're right here? Remember, that's equinox, right? Right here. Or behind the sun somewhere. If you are 5, 6, 7 will be behind the sun, and then 8. So we got 8 sections here. Where do you think we are right now in our orbit around the sun? Based off of what you know about the seasons, right? It's really hot right now. Our last season was winter, right? We're currently in spring, and it's a very toasty spring. So, maybe we're like this around the sun. And we're on this side. It is very toasty. JK, that's a bad example. Don't use that. So we have this orbit around the sun here. Where are we in our orbit? Okay. We're right here. We're on the northern hemisphere, right? Right there. Yep. And once you get done telling me where you think we are in our orbit around the sun and climate do you think Australia has right now, based on what we are experiencing? We know we're on the opposite side of the earth. What kind of weather do you think Australia is having? Post your comments, post your ideas in the teams, email them, fill out the one-pagers, more to come. All right, for this week's work, you are going to create a poster that shows what season you think is where in the orbit. So you're going to get a piece of paper, or you're going to use the PDF off the website, and you're going to fill in what you think each season is. Let's see if we can't do that. So if I think that this season, and we probably don't need 48, if I think this season is fall, I am going to put fall there, and don't copy me because I'm obviously not. Actually, this isn't fall, right? So if I think this season is fall, what I'm going to do is I'm going to fill out this entire section with things that I think represent fall. So maybe I am going to draw a leaf, right? Falling, right? Maybe leaves. Maybe I'll do a tree, and that tree will be scattered with orange leaves, right? Maybe that's, right? Maybe I will write a temperature. Maybe it would be like 60 degrees if you're in Fahrenheit. So I'm going to draw what I think the season is that represents the season that I think this location is. The next season, you're going to draw in this space, and then the next season, and then the next season. Obviously, it rotates around this way, so you're going to have this one, this one, this one, this one. So you're going to tell me where we are as a star, which season we are in. And then you're going to draw a cool picture. I personally would like to print this out and then draw on it. You can go to the school, you can pick up the one-pager, it's on the back side of it, and then I would draw on it. Me personally, this is my way of doing things. So that is your task for this week. Pretty simple, not too bad. All right, I wanted to make sure that I didn't put this video out on Monday. That way everyone can observe Memorial Day and be with their family and think about all the lives that have been lost. So I hope you guys had a great weekend. I hope you observed Memorial Day. And then here's your work for this week. It's only a 4-day week. Have a good day.